Hello, everyone. I am Twa, Information Technology Manager with the State of California, Office of Systems Integrations, CalHERE's project. I'm very happy to also have here with me today Vishal, Enterprise Architect and Managing Director of Deloitte, and Sudarshan, Senior Cloud Architect of Deloitte. Before the cloud modernization, we faced many challenges scaling the system to meet our customers' needs. I was very nervous at some times about the availability of the system during high peak loads. With the cloud modernization, I see the system seamlessly scaling to meet usage demands. This has vastly improved my confidence in the system. We're very excited today to talk to you about our massively complex health benefit exchange system and how we are modernizing the CalHERE's database. We will share with you some background and describe CalHERE's, walk you through the modernization goals and objectives, discuss our database characteristics and modernization methodologies, and go over data theory, our approach to simplifying database modernization. We call the system CalHERE's. It stands for California Healthcare Eligibility Enrollment Retention System. It's the largest of its kind in the country. The system helps people research, compare, check eligibility for health care coverage, and eventually buy affordable health care coverage. One out of every 3 Californians depend on the system for financial help when buying health insurance or verifying aid for eligibility from the state Medi-Cal program. We are talking about 9.2 million user accounts, 450 terabytes of production data, 43 partner agencies, 72 external connections, 540 total servers, 3 geographically distant data centers, more than 1,200 COTS and open source technologies, and 46 environments. The CalHERE's requires collaboration with many, many partners. The modernization itself is spearheaded by the Cover California, the Department of Healthcare Services, the Office of Systems Integrations, Deloitte Consulting, and AWS. The CalHERE's technology refresh has 3 key goals. First goal is to reduce complexity of the monolithic system. The objectives here are to refactor the monolithic application to a microservices-based implementation and improve the system modularity. Our second goal is to improve the overall application performance. The objective here is to optimize system resource usage while improving the end-user response time. Our final goal is to improve system resilience and cost efficiency. Our objectives here were to adopt cost-effective software licensing and accelerate to speed our feature changes that we bring to market. To do these things, we have identified specific implementation focus areas. Our approaches include containerizing and modularizing, faster deployment times, scaling services per demand, and replacing expensive legacy technology. Vishal will share with you the roadmap which has helped us to realize these goals.
Thank you, Toy. So we were crystal clear on the goals of our modernization. We wanted to reduce the system complexity, we wanted to increase the system performance, and we wanted to increase the cost efficiencies of this system. So there were two key initiatives that we targeted towards meeting these goals. The first initiative was to replace the legacy proprietary stack with a cloud-native open source technologies. So this includes the content delivery network, the middleware stack, the rules engine, the entire security stack, the data warehouse systems, and the database systems. And the second key initiative we targeted was to replace or refactor the legacy monolith application into a microservices-based containerized implementation. Our planning also had to factor those non-negotiable business imperatives, such as an uninterrupted velocity of functional changes. There are legislature-mandated policy changes that need to continue to come in as we go through this modernization. And we had followed a risk-averse approach with no system interruptions of this mission-critical system. So we established a blueprint for a 18-month incremental or evolutionary modernization roadmap in which every change that we did in our architecture did three things. Every change was atomic in that, that you could either go forward with that change or roll back just that change. Every change brought tangible benefits to the carrier system, which we measured against the key performance indicators that we had established really early in the program. And every change brought the architecture one step forward towards its target state. So if there are any Formula One car racing fans in this room like me, you'll see that this journey is like a Formula Grand Prix season, where targeted modernization changes are applied and measured on the car, and they are measured in every race, so that at the end of the season, you have a highly improved car. We have now transformed more than 80% of our legacy monolith into a open source microservices-based architecture. And we are more than halfway through in our modernization journey of replacing the legacy proprietary stack. I'll give you a couple of examples to make this really more real on the impact this change has had. When the American Rescue Plan Act was passed, Calliers and the state of California was one of the first systems in the country to implement that plan, and we rolled out that plan. So imagine having a neighbor who depends on the system for health insurance, and the person sees right after the plan has been passed, within a few weeks, they're able to get the benefits. From $400 per month, example, that they're paying for health insurance, the cost comes down to $1. And they're able to provide those benefits to their family during this time of urgent need. The second example I want to give you is the couple of days after we went live with our containerized architecture, we unexpectedly received twice the workload from one of our largest partner agencies. So, we were able to process these workloads within a couple of days because the system was able to scale out effectively, and thanks to this modernized architecture, it was able to process this load very efficiently. Next, I'll start sharing the characteristics of the Calliers database and our modernization roadmap for the database, which is really the intent of this presentation. Calliers has a very large transactional database. As Aptua mentioned earlier, it has 450 terabytes of production data. Out of this, 150 terabytes of transactional OLTP data is hosted by our databases, and it is distributed across 8,000 tables. This database has over 460 stored procedures and over 4,500 queries, which is embedded in the application code. This database also has over 15 million cases and has over 37 compliance and security controls associated with it. So it is no surprise that operating such a large database is going to be an expensive effort. It uses proprietary legacy technology, database technology. It has non-ANSI SQLs embedded in the application code. And it has a costly capital expenditure licensing model, which does not adapt easily to the cyclical nature of a health exchange business. Now, we always knew going in that modernizing out of this database is going to be a complex effort. But the rewards from the modernization, they far outweighed this effort. So we wanted to put ourselves in a position where we are able to easily adopt innovations. As new capabilities and features come in from AWS, we are able to easily adopt that into the Calliers database. And we wanted to save the state a lot of money as well in the process. So we also wanted to use this opportunity to improve on the quality attributes of the system, the performance, portability, security, resiliency. Today, our legacy database, it takes over 20 minutes to recover from a failure. But by going to an Aurora Postgres database, we expect that time to be cut down to less than 2 minutes. Scalability is also very important to CalHERS, especially because of the ability to react to these massive peaks and valleys before, during, and after the open enrollment period. So how did we approach this modernization? We leveraged the AWS's leading practices, the Database Freedom Program, now it is called the Database Migration Acceleration Program, and its industry-leading tools, the schema conversion tool and the data migration services to migrate these assets. We also saw an opportunity to supplement those assets, and we call our approach Data Fury, and we'll discuss that later in our section. Working with the state, we executed 3 controlled steps: discover, migrate, and operate. And I'll go through each of those. First, we started with a detailed discovery and planning exercise. Our intent was not just to modernize the databases, but really we wanted to innovate and maximize on the impact that we bring to the CalHERS system. So we did a bottom-up discovery of the CalHERS system database portfolio. We identified the list of database assets. We also looked at the application to application and application to database mappings. We also gathered the database licensing footprint and its usage metrics. We used all this information towards establishing the target state database. We also refined the level of effort needed for this modernization, and we established a very detailed database modernization work plan. We worked closely with AWS in this exercise, and we assessed this target state database against AWS's well-architected framework pillars of portability, availability, cost, operational efficiencies. And we applied the learnings from that assessment really early into our database design. By doing that, we were able to improve the cost to quality of our implementation. We leverage AWS's schema conversion tool and data migration services to understand the complexity of migrating the SQLs, the data types, and the data to this target architecture. Our sponsors and business executives, they wanted to know more. They wanted to understand what is the level of funding needed for that effort so that they can calculate the return on investment for this large modernization exercise. And I'm sure that is top of mind for most of you here. How do I convince that what is the level of funding needed? So we built capabilities on top of the schema conversion tool and the data migration services to define, to provide insights which apply to all levels of our organization. So at the sponsor level, at the business executive levels, it gave them insights into the total level of funding that was needed and the return on investment that they could get from it. At the application architects level, they could see the different areas of the application that had the highest complexities. And for the developers, it could tell them the lines of code that would be changing as part of this modernization effort. So we have packaged all these capabilities into the Data Fury approach. So next is the migrate phase. We leverage the SCT and the DMS tools, fantastic tools. We use these tools to migrate the SQLs, the data types, and the data into the target database. We also migrated the compliance and security controls during this particular phase. We saw an opportunity to simplify and to accelerate this modernization effort. And we brought in multiple automations. I'll cover 3 key automations that we brought as part of this exercise. The first one was we automated the refactoring of complex SQLs and the complex data types into the Aurora Postgres database. So I was at my second point where we implemented automated JUnit test scripts to improve the effort needed for validation of the migrated queries. And the third very important thing we implemented was a 4-point techno-functional validation of all these migrated assets. We have packaged these capabilities into Data Fury, and now I want to talk about the quality attributes of the system. Really early in the design phase of the project, we analyzed and we incorporated tactics for improving the quality attributes. Performance, scalability, availability, security. during the migrate phase of the project, we validated the impact of these tactics by executing a very robust suite of validations. Like we executed detailed performance test runs, security validation scenarios, and we executed a number of validations availability scenarios. And any gaps that we identified, we remediated those gaps as part of the migration phase validations. We also kept a very close eye on checking if we have inadvertently introduced any vendor lock-ins as part of this implementation. And we did that by continuously scanning the source code for portability anti-patterns. So both this performance baseliner and the portability analyzer has been packaged into Data Fury. Now, I want to discuss the operate phase of this project. So the database, the Calliers database, it is the heart of the Calliers system. And just like the heart, it consumes maximum energy from our operate team. It is the priority of our operations team to see that this engine is running efficiently. By going to the Aurora Postgres database, we expect to bring in a lot of simplification in the operate activities for the database. Things such as provisioning of new infrastructure, taking backups, applying patches and upgrades. We expect that all those activities to simplify. But in addition to that, for an effective transition of these activities within our infrastructure operations team, we see a need for executing several activities. We have over 200 standard operating procedures for maintaining and operating the Calliers database. We'll be updating all those SOP documents. We'll schedule day in the life cycles, which will really give an opportunity for our operations team to practice those routine database administrative activities. These include provisioning of new infrastructure, monitoring application performance, and remediating issues. And it will also give them an opportunity to address any atypical conditions, such as if there are any failures, or if there are alerts, or if they have to do repairs. So those will be practiced during the day in the live session. Then we will be executing a soft launch of the database several weeks in advance of the actual cutover. So what does that mean? Right? We are looking at 150 terabytes of transactional data. We'll be doing a one-time bulk upload of that data into the target database. And we'll keep that database in sync with the legacy database till the day of the cutover. And we'll do that using the SCT and DMS tools, which are fantastic in doing these heavy bulk load activities. So what this will do for us is it will reduce the total amount of outage that we need during the actual cutover. And it will reduce the stress for our operations team. Finally, we'll create a very detailed cutover plan and a hypercare plan. And we will have our team do mock cutovers, which is they will trial these cutover activities several weeks in advance of the actual cutover. So by doing that, it will reduce surprises for them going into the cutover, and it will allow for a seamless and highly successful database modernization. Next, Sudarshan, my colleague, will talk about our Data Fury and our approach to simplifying database modernization.
Thank you, Vishal. All right. Vishal just had talked us through the various phases of Calliers database modernization journey. Now, you heard the word Data Fury. So you may be wondering, what is Data Fury? Our automation-first migration approach, Data Fury, extends AWS migration tools, reducing the development and testing efforts and simplifying the overall database migration. Let me double-click more on Data Fury. During the assessment phase, Data Fury provides refined estimates for business executives to make informed decisions. During the migrate phase, Data Fury automates the SQL conversion, data migration, and the validation, reducing the cost and complexity of the manual rewrites. Additionally, during both these phases, Data Fury keeps a very close eye on the quality attributes of the application and migration. Next, I'll talk about how Data Fury provides refined estimates during the estimation process. Okay. As you are aware, the schema conversion tool, SCT, extracts the SQLs from the source code and provides the estimated conversion complexity. Data Fury extends SCT in 3 major areas: improved scanning of the code, improved mapping of data types, which leads to improved estimation of efforts. Let me start with improved scanning. SCT works very well against standard SQL notations. However, it generates a lot of false positives, and it does not extract dynamic queries from the source code. Data Fury extends SonarQube and implement enhanced search capability. With that, we are able to extract the dynamic queries efficiently, allowing refined estimates. Now let me talk about mapping data types. Mapping the data types to the appropriate target data types is one of the crucial activities. SCT comes up with many out-of-box data type mapping between the source and the target database types. For example, Oracle's number data type could be mapping to 3 different Postgres data types. Could be numeric, could be big int, or could be double precision. Mapping the data types with the knowledge of the application and the knowledge of the data set is crucial to reduce the amount of manual rewrites needed on the application. Data Fury solves this problem by profiling the data set, as well profiling the application, and coming up with a recommended compatible data type mapping, thus allowing the amount of manual rewrites needed for the application. This helped us significantly reduce the amount of complexity in the application code migration in CalHeres. Next, let me talk about the improved scanning that we saw, and the improved mapping led to refined estimates. SCT reports raw findings from the code scan. Curating these findings is a manual error-prone process. So Data Fury automates this curation process and comes up with a refined level of estimates. It provides module-level insights of the entire modernization effort. Now we have seen how Data Fury helped provide refined estimates during the assessment phase. Next, let me talk about how Data Fury helps automating the migration processes. SCT does a fantastic job of migrating the queries and then doing the code-based updates. However, it was still a lift and shift effort, carrying the legacy's technical debts. In CalHeres, this approach migrated non-ANSI SQL functions to the target state architecture. Similarly, DMS migrates large volumes of data at scale seamlessly. However, we felt a need to expand the data validation services in DMS. Data Fury expands both SCT and DMS in 3 different ways. Let me start with modernizing to ANSI SQLs. SCT's conversion approach implements non-ANSI functions with extension-based approach, as you may all know. This lift and shift approach isn't performance efficient. Data Fury provides a configurable framework that maps a legacy construct with the open standard function constructs, allowing portability to the entire migration effort. This transforms the application code into high-performing ANSI SQL constructs. After the SQL migration is done, next, how do we validate all these migrated queries, which was a humongous task for CalHeres. Data Fury implemented side-by-side validation of all migrated queries, validating A, the query syntax, B, the query output against dynamic parameter sets. This unit testing approach validated each migrated query comprehensively ahead of the functional testing cycles. Having talked about the query migration, let me switch to data migration. DMS migrates large volumes of data seamlessly. Also, DMS validates large volumes of data seamlessly. DMS operates validation on tables only with primary keys. Data Fury expands on DMS capabilities by validating the following: the data structures, comparing all the schema elements from the source into the target, confirming that all the schema elements migrated in the same shape and form from the source into the target. Number two, validating all the data leveraging a MD5 hashing algorithms on all tables that includes primary key as well as non-primary keys. This provided a comprehensive validation of data for CalHears. These Data Fury capabilities provided confidence as well as integrity, validating the integrity of the database migration. Thus far, we have seen how Data Fury accelerated our migration as well as assessment phase. Next, let me talk about how Data Fury helped validate some of the key quality attributes in CalHears. I'll start with portability, and then let me switch to performance after that. As you know, migrating queries is not easy. It is a very, very time-consuming process. Hence, it is critical to confirm that the migrated queries follows open standards. For example, Oracle's months between function could be written as to its ANSI equivalent using extract construct. However, all database engine does not support all ANSI functions as well. Hence, it is important to confirm, provide a framework to be able to map all the legacy constants to the open standard functions. Data Fury solves this problem in two different ways. Data Fury scans the migrated code and confirms and provides the ANSI compliant percentage. Number two, Data Fury provides a configurable framework that provides configurable frameworks for mapping all the legacy construct with the open standard functions. This allowed us to keep the migrated queries portable, which is very crucial for a future database-ready architecture. Now let me switch to performance. Assessing the performance impact of the migrated queries, especially with data at scale, will be on everyone's mind. Data Fury implements a granular SQL monitoring. This framework expands the performance insights provided by AWS, providing detailed SQL performance statistics, comparing with the legacy SQLs. This allowed us to A, prioritize, B, fast track our tuning cycles. In CalHears, we had applied 60+ tunings across 3 different database areas: infrastructure, database configuration, and query execution plan. This provided us an early performance baseline ahead of our testing cycles. Now let me recap Data Fury. Data Fury supplements AWS migration tools to provide a simplified and automated database migration. Data Fury provided the following: improved scanning and automated analysis of SCT findings, providing insights to all levels in the organization. It automated the SQL conversions and pre- and post-validation, significantly reducing the cost and the complexity from the manual rewrites. It confirmed ANSI compliance and automated the performance baselines, reducing the complexity of the migration. Data Fury has been a tremendous accelerator for CalHears' modernization journey. Like Vishal said, this reduced our database migration effort by a third. We are looking forward to collaborating with the broader community on standardizing this approach. Now I'll turn it back to Tua for his closing remarks.
Thank you, Sudarshan. We firmly believe that the database modernization journey will establish a nimble, future-ready solution. This will form a foundation for accelerating the adaptation of database innovations into the Cohere system. But what does that mean? We're talking about innovations like refactored databases, microservices-driven data models, micro-batches, and workload segregation, leveraging replication on demand. This modernization journey will not only set the standard for the future large-scale modernizations, but the successful completion of the updated Cohere system will reinforce Cohere's as a gold standard among the health insurance marketplaces in the country. Thank you for joining us today in this presentation. We're happy to take any questions you may have.